Good evening, everyone. I am going to make a recording for chapter 1. Let me now connect my document camera, which got disconnected. Let's see if it allows me to share. Should be able to share my screen. Okay, so let's see if this comes out the way I wanted to. Let me focus and flip this. No, didn't work. There it is. Okay, so by this time, you should be pretty much done with chapter 1. I have seen that many of you still have a lot to go, but it's fine. I will be doing the recording for this unit, and it is basically the review that I have up on files. I just want to go over a couple of things, especially the more difficult ones. I've got my calculator ready to go. Solving equations is something that you should already know. It's a skill that you should have come with in this class. Maybe you don't remember, but it's okay. We just need to practice that. All right. So this would be the answer key. All right. You will be having some of these problems on the test, of course, but I'm not going to go through every single one of them because I know that some of them you know how to do. So let's deal with some of the fraction ones, maybe like this one. Okay. When you are dealing with the solving of a variable, that is in the numerator. Zoom in here for a bit. Okay. What you want to do is be able to have it by itself. That means isolating. And so I need to get rid of this 26, right? So I'm going to rewrite this again. I'm going to use a different color. And what we want to do is be able to get rid of this negative 26. Okay. And that then gives me positive 26 on the left side with a k plus 10 on the right. It goes from a very complicated problem to a very easy problem to do, where I just subtract 10 and k equals 16. You can always test your answers, if they're correct or not, by plugging them back into the original and check if the answer is correct. The answer key for this is already up there, so please check to see if the answers are correct. Okay. I wanted to just go over one of the fractions. Okay. All right, for number 4, which I think would be the next more complicated problem, you've got improper fractions here, improper fraction, and you've got a mixed number here. You want to deal with that right away. You want to be able to convert that into an improper fraction. So you basically multiply 6 times 2 and add 5. Okay, so 6 times 2 is 12 plus 5. And then you keep the same denominator, don't forget. That was a p, and then you do 22 over 3 equals negative 8 over 5p. I always have the habit of putting negatives in the numerator. Okay, I think this is zoomed in way too much. Okay. All right, so what we want to do is we want to basically get the p's on one side and the numbers on the other. So what we want to do is basically get this one to the left and move this one to the right, but we've got fractions to deal with, right? So what I want to do is I want to be able to get rid of the fractions from the very beginning so I don't have to deal with them in any part of the problem. So what would you like to do? There are several ways. You can move these already as they are, just add that, subtract that one, or you can deal with the fractions first. It's really up to you, but I always just like to basically get rid of the fractions already, okay? So I need to find the common denominator of all these 3. So how do you find a common denominator? How you would do it? Let me grab this. In order for you to find the LCD, you basically start with each denominator and you run a list of all the multiples. Okay, and where they match, that's the LCD. So you start out with 5 and you keep on finding the multiples. So 5 times 1 is 5. 5 times 2 is 10, 15, 20, 25, 30, and so on and so forth. You can just continue it to a few numbers. 3, 6, 9. I still don't have a match, so I'm going to keep going. 12, 15. Oh, here's a match. Okay, here's a match. All right, so I can stop there in the meantime. 6, start at 6, 12, 18. So this is 6 times 1, 6 times 2, 6 times 3, 6 times 4. That's basically what I'm doing, right? 30. All right, so I don't have a 15, but I do have a 30, and I do have a 30 here. And I know that if I continue this, 3 goes into 30. So if I keep adding, that 30 is my LCD. Okay. That means that 30 goes into all those 3 numbers evenly. And so what you want to do is you're going to use that to multiply by the entire equation. And I mean every single piece. There are 4 pieces. Don't forget about this one. You can put that over 1 if you'd like. So I'm going to take 30 on the left and on the right side, and I'm going to multiply it by every single fraction or every single term, basically. So if I multiply these 2 together, this, let me use a pencil here. Oh, I have no letter. Wait a minute. Okay. So if I multiply this, I get 1 and 5. So 6 goes into 30 5 times. I then multiply that 5 left over because now I don't have a denominator anymore. And I just multiply by 17. So that gives me 85, and I bring down the P. Okay. The next one is it's as if I put the 30 here. Okay. And I do exactly the same thing. So 3 goes into 30 exactly 10 times. So 10 times 22, wrong one, is 220. Okay, that's the reason why you find LCDs, because you know that that number is going to evenly go into here, which will cancel each of the fractions. All right, next one, let's put the 30 right here. Remember that there is a negative, so I'm just going to put that down. With the pencil, I'm going to take that 5, and that's going to go into 36 times. And that's basically going to be 6 times 8, which is 48p. And in the last part, there is nothing to cancel. So 30 just multiplies with 1. Don't just leave it as 1 because it's not correct. And from here, you can solve the rest of it. Okay, so I just wanted to get you started on this problem because I know some students, you know, they get stressed out because they've got some fractions improper and mixed and might be a bit scared. So that's how to get you started. You can then finish it up and check the answers that I have on Canvas. All right, I'm gonna go now to slopes. Okay, this is something that I hope you remember. You can definitely write these formulas on your note card. Okay, and here's one of them. This is the slope formula. So y2 minus y1, x2 minus x1. This is basically the rise over the run. Rise is always up, down, which means the y value, run is left and right. Okay. So when you are doing these, you always have to subtract y's with y's, x's with x's. So if you were to label these, it would be x1, y1, x2, y2. You could have started labeling this like x2, y2, x1, y1. It doesn't matter, just as long as you keep the x, the ones together, the twos together, and that the first one is an x and the second one is a y. Now we can plug this in, and I'm only going to do one so you can do the rest. And so the slope will be y2, which is -5, minus a 17 over. So the formula already has this negative right here. That's this one. Okay. And then the second one will be -6 minus 16. Again, that was part of the formula there. Okay. So you have to know, obviously, your rules for adding and subtracting. If you don't use a calculator, please do so. Don't mess up in these easy answers. So that's a negative 22 over, again, the bottom, you add the numbers because they are same signs. So same signs, you add the numbers, keep the sign of the larger, which is they're both the same, so it doesn't matter. The bottom one, they're also both the same sign. You look to the left, according to Beyonce, you will always want to ask, what sign? Where's the sign found to a number? And she'll say to the left, and that's how you know it's this one. So 16 is negative, 6 is negative, they're both the same sign, you add them, you keep the sign of whichever because they're both the same. So it gives you a slope of 1. Okay, and that would be the answer to that. All right, you can do the next one. For the bottom portions, if we want to find the slope, like I said, slope is a rise over a run. Okay, I'm going to put the signs here. The rise is always up or down. The run is always left and right. If you are going up, it's positive. Going down, it's negative. Just look like the coordinate plane. If you're going right, it's positive. If you're going left, it's negative. So what we're going to do in order to do or find the slope, you can do this 2 ways. You can extract the points for each of these and do what I did up here, which is actually technically a lot of work. Or you can literally just count the rise over the run. It doesn't matter if you go from this point to the bottom, that point to that. It doesn't matter. The first thing I do want to note is the fact that my line is falling. So you always read graphs from left to right. Always left to right, left to right, left, right. In this field, this is like falling. This line is falling. So this is going to have a negative slope. Just before I begin, I want to make a note of that. So I know that my answer has to be negative. On this one, it's also falling. So this will also be a negative slope. Okay. All right, so how do we do this? If you do rise over run, if I want to go from here to here, and you're supposed to do rise first, I would not go up because that's not going to get into the second point. I would have to go down and right. So you're basically creating a right triangle. Or you could go from this bottom up, and it doesn't matter. Go up, left. It doesn't matter. You just have to make sure that you count it correctly. So let's go from the first dot to the second dot. So if I go down, it's going to go down 1, so minus 1. It's minus because I went down. And then I run 1, 2, 3, 4, 5 spaces to the right, which is positive. And that gives me that slope. Now, what if I go the other way? What if I go from 2 to 1? I go up 1, but then I go left 1, 2, 3, 4, 5. And that means I went 5 to the left. These two are exactly the same. If you have a negative 1/5 or a positive 1 over negative 5, these are both the same. As long as there is one negative, you're good to go. So you can do this either way, from point 1 to point 2 or point 2 to point 1, as long as you put the numbers in the correct place. When you are moving up or down, the number goes in the numerator. When you're moving left or right, the number goes in the denominator. Okay, you get the same answer. There are 2 different dots on the same line. Okay, let's do this one. I wasn't going to, but let's just do it because I'm just going to count. I'm actually not going to do the math. This is point 1, point 2. Let's count both ways. Let's go first. Let's go from 1 to 2. So if I want to go from 1 to 2, I have to go down first and then to the right. 1, 2, 3, 4. Yeah, it's looking straight to it. So I went down 4. And I go 1, 2, 3, 4, 5, 6, 7. Okay, so that's negative 4 sevens. Or if I go from 2 to 1, grab another color. Then I go up 1, 1, 2, 3, 4. And if I'm looking straight at it, then I can start walking. So this is like going from your house to school, right? But you can't go in a straight line because there are buildings. So you have to go up and down the blocks, right? So for this, I went up 4. And then I go, I'm standing right here. So I go 1, 2, 3, 4, 5, 6, 7. And I went 7 left. And again, these are both the same answers. Both of those answers would be accepted, let's say, on a test. So make sure that you know how to count this. You know how to, find the slopes. If it's slanting or going down, it has to be a negative answer, whether the negative is in the numerator or the denominator, it doesn't matter, as long as there's only one single negative. Okay. All right, let's go on to the next one. When you are sketching graphs of lines, okay, you always want to, well, there's many ways of sketching, by the way, there's many ways of sketching lines. The first one and the easiest one is to have your equations in y equals mx plus b, which we see as the top two, okay? Knowing how to find the slope from a graph now allows you to have a graph, an equation given to you and then graphing it, going backwards. This next one is in standard form, so you can do two things. You can graph by using the intercepts, which is something that is taught in the lesson. And this one is a special case because this one only has one variable. So when you have an equation with one variable, it will either be the horizontal line or a vertical line, completely straight. The ones that have two variables will be diagonal lines with either a positive or a negative slope. I'm not sure if you see my image correct or not. But they're either positives or negative slopes, diagonal lines. All right, so I'm going to do one from the top. I'm going to do the negative one because that one also always confuses students on where to put the negative. Again, don't worry about where to put the negative, just put a negative on one of the numbers. So my slope, let's put it in the numerator. Let's just see what happens. And my b is 4. The b is 4 means that's the y-intercept. That's where you're going to start. So that's an actual dot on the y-axis. So I'm going to look at the y-axis, find this 4 and put a dot right here. Okay. From where I start to the movement, so think as m as the movement from a starting point. So if I ask you, how long does it take you to school? Automatically, you might be thinking, well, it takes me like 20 minutes, but you're thinking from home, right? But if you are at the store, it won't, at a specific store, it won't take you that long. What if you are coming from vacation from Northern California? It won't take you the same amount, right? And you can't give directions to someone if you don't know where they're starting from, right? So you need always a starting point, which is this y-intercept. From here, you then move. M is for movement, so we're going to move. Now let's check out the arrows. The number on top is always rise, and the bottom is run. The number on top is always the vertical movement. Because it's negative, I'm going to go down. And because this is positive, I'm going to go to the right. So this is the movement from this point. I already have this point. I'm going to go 7 down. 1, 2, 3, 4, 5, 6, 7. And then go over 4. 1, 2, 3, 4. Once I plot this, I can see that my line is going to be a negative slope, which matches my slope. And that is enough for me to graph this line. Okay. Now, had someone said, oh, you know what? I chose the negative to be on the bottom. Well, good for you. But if you start at the 4, because you're always going to start at the y-intercept, and you attempt to go up and left, okay, you're going to run out of boxes. And I don't want you to be ghetto and then try to add grids. Like, don't do that. If this does not work for you because you run out of grid, you don't do it. You just change that negative to the other side. Okay, that's all you need to do. All right. Let's go ahead and do this one. You can take this and make it into y equals mx plus b. The only thing that I have to caution you about that, and you can make it a habit if you'd like, but you also want to be able to solve these differently or graph them differently. It's the fact that sometimes when you make a standard equation that you don't know how ugly it's going to be into this form, sometimes you end up with fractions here. And if this is a fraction, it makes it really difficult for you to make like whole number movements. Here, it was a 4, so I knew where to plot it. But if it's like a 5.25, you have to plot it and then figure out like the movement. It's a little bit difficult and hard to figure out sometimes. So in this case, what we want to do is we might want to try the intercept table, which basically says, okay, I don't want to move it, right? And I'm not going to put it in this format. I'm not going to. I'm just going to use what I have. This is called standard form. The easiest way to graph a standard form is by doing a table. From any equation in this world, you normally have two variables. There's some that you have three, but in this case, you've got two. You are allowed to choose one of the variables, like guess whatever number you want, just plug in any X value and you'll get the Y, or you can pick a Y and get the X. And this is basically the intercept method. So I'm going to choose a 0 for X and I'm going to choose a 0 for Y. And that's basically what I'm going to do. I'm going to plug them in and solve. So the first one, I decided to choose 0 for X. So that'll be 0 here. Okay. What is that going to do? It's going to make this go away. And it's, when I solve, I'm going to get Y equals -2. So the Y that pertains to this X equals 0 value will be a -2. And that would be a dot on my graph. Okay. So I choose a variable to find its pair. That's basically what I'm doing. All right, over here, I'll then go the other way. So I'm going to do 7x minus 5 times 0 equals 10. This basically gets wiped out. So I get 7x equals 10. And when I divide, I get 10 over 7. Now let's see how ugly that number is. I'm going to take 10 divided by 7 and see, it's an ugly number. It's like 1.42, but you put the exact answers on that table. And you know that that's 1.4. So when I plot these, one dot is going to be on the y-axis, one dot is going to be on the x-axis. This 0, -2 is basically, let me try a different color. This is your y-intercept. Y-intercepts are when you let x be 0. And your second point, if I put them in a point format, that would be your x-intercept. Okay, so 1.4 comma 0 is about here. And all you do, the dots. If you want to get more dots, then good for you. You want to test it out. All right. Okay. All right, the last one is y equals 1. And for this one, it's very confusing for students to memorize when it's a horizontal and when it's a vertical. But basically, y equals 1 tells you that y is going to be 1 every single time. It doesn't matter how many points you take. This is going to be standard, and it's going to be the same all the way. So what is x? X doesn't matter because it doesn't exist. So you could actually plug in any points you want. And when you plot them, 0, 1, 1, 1, 2, 1, notice that you get a horizontal line. Okay, so you can do two things. You can memorize that any y equals number line is a horizontal line, or make a table. So y equals a number line are horizontal lines, x equals number are vertical lines. And this should be on my notes if I'm not mistaken. Okay. Let me just double check something. Yes. Okay. All right. The next piece down here is pretty easy. I really am not going to do both of them, but slope intercept form is y equals mx plus b. And I'm just going to explain it and let you figure it out. Okay. My answers are up there, so you can check out how I got the answers. But when you're given a slope and a y-intercept and you're asked to give me an equation back, you just basically take these and plug them in for the m and the b. Slope is m, y-intercept is b. Okay, so you can definitely figure that out. Okay, all right, let's move on to the more difficult ones here. There's 6 pages. All right. Now, this one is something that I already went through. I believe it was the first, no, the second day, I think. If I want to write an equation in slope intercept form, it's this one. Okay. I'm going to do the harder one, which is this one. Okay. I need M and I need B. I don't have M and I don't have B. I don't have any of that information. I do have it on the bottom of this page, page 2, but not on here. So I'm going to have to do some work. First of all, I need to find the slope. How do I find the slope? Just like we did earlier. You can label x1, y1, x2, y2. Subtract. So I'm going to do this minus that, this minus that. So I'm going to go -4 minus -3 over -1 minus 5. Notice that the top one has a double negative because the formula contains a negative in the middle. And it just so happens that the 5 is positive, so I don't have to add or put anything. And this value over here is already a negative. So I have to put that double negative. Okay. All right, let me disconnect my charger here. All right, so let's do the math. This is, sorry about that. It's a -4 plus 3, which is a -1. That's a -6. So my slope is 1/6 because those negatives cancel. So I've got my slope. And now I want an equation of this form. To find B, you can plug in the M and pick a point, but then you're going to have to deal with fractions because this is a fraction already. This is 1/6. So I don't want to deal with fractions. I am going to pick a point. I'm going to choose this one because it has the least amount of negatives. And I'm going to use the point slope formula. Y minus y1 equals mx minus x1. And I'm going to plug in my slope in here. And I'm going to plug in my x1, y1. Okay. So this is my x1, y1, and here's my slope. So let's go ahead and do this. Y minus -3 equals my slope 1/6, x minus 5. Okay. Now that I have that, I'm going to make this a plus. Okay, just because I'm going to run out of space. I already know me. Okay. I don't know why that's so big. So. All right, I have more space now. All right, so let's zoom out a bit. Okay, so over here we've got something like no space. Okay, you multiply the number in the top, which is called the numerator, to the right-hand side, and you multiply the number on the denominator to the left. So it's like having a 6 on this side. So that'll give me 6y plus 18 equals 1x minus 5. And that can be easily turned into this when you subtract the 18 and divide by 6. So let's go ahead and do that. The 1 is optional, okay? You don't have to put the 1 in there, but you can just leave it as x, okay? These are the same sign, so it means you're going to add and keep the sign of either, it doesn't matter. And then the last step is divide everything through by 6. So my final answer would be y equals, now you can put it as x over 6 or 1 over 1x over 6, which is the same thing as this. Your slope should come back out, okay? And then here you'll just have like 23 over 6. Leave things exact. Don't try to divide and get fancy, ugly answers. Just leave them alone. The whole point of this is the fact that you have taken an equation in point slope form, made it into y equals mx plus b without ever having to deal with fractions, adding, subtracting, multiplying, or dividing, okay? So use this trick, you'll always get the right answer and in a very easy manner. Okay, in terms of the bottom inequalities, okay, these are not difficult to solve. but I am going to solve maybe just one to get practice on both the roster and interval notation. Okay, so let's try this one right here. Just because the variable's on the right, and that means some students make that really difficult. So 96 less than -8. I'm going to distribute that. So it's -8b. And then you have a negative times a negative. So make sure that you know how to multiply your negatives and your positives. And if you don't, just use your calculator. All right. So negative times negative is a positive, and that's a 56. All right. So I'm trying to isolate my variable. So I am going to move that over. It's 40. And here's the thing. Whenever your hand physically does dividing by a negative number, your inequality has to flip. So instead of going this way, let me just highlight it so you can see it. Instead of now going this way, it's going to go that way. All right, so now you drop the variable and you divide this, and it doesn't matter if the answer is going to be negative or positive on the other side. It just matters that when you divide by a negative, this inequality flips. Now, this is hard to graph because your variable is on the right side. So what I'm going to do is you're going to pretend that I wrote really dark in here. And I flip the page. I'm going to see it here. So, let's see if I flip the page, I have b less than -5. So you always want to make sure that when you rewrite these, you always put the variable first. If you see that the big mouth is opening to the -5, then you have to write it like that. Okay? So when you write it like this, make sure that you write it same way and you don't make a mistake. Roster notation would technically be this. This is roster notation. Basically what you got with the variable first and b colon, or sometimes they have b with a line. Instead of a colon, they'll have this. And it just means b such that they're basically stating that b is the variable in the answer. Okay, so let's graph that. This is b less than -5. So I'm going to make sure that I remember those spaces. Look at the notes that I have up there. When it's a less than with no bar underneath, it is an open circle at that. Here's a -5, it's an open circle. And it says b less than, b is the shading. So basically the shading is less than -5. Less than means to the left. So I'm going to take this and on top of the graph, just shade it like that. Okay, and that's what the graphing looks like. In order for me to put this, let me zoom out a bit. So in order for me to put this in interval notation, I'm going to look at the graph. The graph is always very helpful. You always put interval notation, okay, in brackets or parentheses, because this doesn't have a bar underneath, it's going to have parentheses, okay? The other thing is you always start from left to right. You're going to read these from left to right, left to right. So left is not a specific number, right? Because if I had this line any longer, I'd keep drawing and I'd keep shading, right? So this one, everything on this side is shaded. These extremes are -infinity, and over here it's +infinity. So if my shading kept going to the right, then they would be the infinity, but you always have to write them left to right. So if I'm reading from left to right, like we read here in the US, I start where it's coming from -infinity and it stops at -5. Infinities are always parentheses, and this is a parentheses because there's no bar underneath. And that's how we would write this answer in interval notation. Okay, please practice these. More importantly, how to go from roster to interval, interval to roster. So these two basically mean the same thing. It is on one of the pages in your online textbook. All right. Let's go to page 4. Let's see what we can find here. Okay, I'm gonna skip this for a minute. That's a little bit of geometry. I'm actually gonna go over here and I'm gonna do one of these, maybe, and if you guys can do the rest and tell me if you have any questions. Okay, I'm gonna take a difficult one. Let's see, let's try this one. Okay, so I want to find the equation in y equals mx plus b of a line that goes through this point. So basically this point has to be contained somewhere in there, but it's perpendicular to this line. Okay, now make sure that you don't do the following. If you take these two values and you plug them into x and y, you're basically testing if this point is on this line, which is not going to be correct. Okay, so this is a separate line from this one. All you're going to use this line for is for its slope. All you're going to use this line is for its slope. Same thing here, same thing here. You just have to know which slope you're looking for. Okay, so any line that is parallel to this line will have a slope of 5/4. But any line that is perpendicular to this line will have to have two things. It will have to have a swapping of the fraction and a sign change. So if this is a positive, it's going to go negative, and then it's going to flip. The negative goes wherever you like. It doesn't matter. Okay. So I'm going to be now using this point and this slope into the equation of y minus y1 equals x minus x. Oops, I just forgot my n. How did I just do that? So okay. So I'm going to use this formula to plug this in and that in, and then go from here to here. That's the easiest way to do it. You can always use this if you like. I just think it's more complicated, especially when you're dealing with fractions. So I'm going to use those pieces of information to go here. Okay. So this is what we have. Y minus a -3, so that's a positive. Slope -4/5, parentheses, x minus 5. So I took it from here, this one and that one. I had a double negative on here, so that's why it became a positive. Now I'm going to take this and distribute, and I'm going to take this to the left. So if I forget, I'll just put a 5 here. So I've got 5y plus 15 equals -4x plus 20. Then I subtract and solve for y. 5y equals -4x plus 5. Divide by 5. Here, let me do that with a different color. I should end up with the same slope that I began with. And these can divide or not. It doesn't really matter. In this case, it turned out that they did. So practice these. The perpendicular ones are the ones that confuse students the most, because a lot of students will accidentally take that slope exactly as it is, and you have to remember to flip it and change the sign. Some students remember to flip it, but don't change the sign, okay? When you are asked to find the parallel equation through a different point, you just take exactly that same slope and work with that point. That same slope and work with that point, okay? So that's all that I have on lines. I believe that's it, yes. And now I'll go to the geometry and then do function notation at the bottom. All right, so here these are fairly easy if you know Pythagorean theorem, okay? It says find the missing side. Pythagorean theorem is a squared plus b squared equals c squared. Now, that's easy. The difficult part is knowing who goes where, right? Basically, just remember that c is the hypotenuse, it's the longest side, it's the hippo. That's why it's the longest, so that's the hypotenuse, okay? How do you know which one's the hypotenuse? You look at your triangle. Let's suppose you're a bird flying over this triangular room. Normally all rooms are squared, but this is a triangular room. You're flying over it, and you ask yourself, let's look at the 90 degrees. So you're here, you're standing right here. The side opposite to you is the hypotenuse. Okay, these two are your legs. If you stand right here, if you're now into the room and you stand right at that corner, right here, you're standing right here, you're that dot, that little box, and you open up your hands, you will be touching those two sides. Those two sides are called your adjacent sides, which are sides that you were actually touching. They are the legs of the Pythagorean theorem hypotenuse triangle. So therefore, the leg that is opposite to you, the leg that you're looking at, not touching, is your hypotenuse. In this situation, and it doesn't matter how they draw it, you're standing right here. You open up your arms, you're touching these two right here. So these are your legs of the hypotenuse, and this is your hippo. Not write it backwards. This is your hypotenuse. Okay, so I'll do one of them. Let's do the left one. And all you're going to do is plug these in. So this is A, this is B. It doesn't matter who's A and B. You could swap them, right? But the important one is this guy. And that is C. That'll be by itself squared on one side. So this will be square root of 11 squared. Oh my, what was that for? Do I have a meeting? Plus square root of 14 squared, because you have to take that side and square it, and that equals C, which is x squared. Now the nice thing about this problem is that because they are square roots, when you square a square root, these go away, so you end up with just 11 square root, that's 14, and that's x squared. So here you end up with 25, and to solve for x, you have to take square root of both sides, okay? So again, this is up there. Practice it, please. Normally, your answer would be 5 and -5 if you were just solving an equation. But because you're solving a real life situation in which you're dealing with lengths of sides or just length in general, you do not give the negative answer. You just give the positive. So technically, this is x equals 5 and -5, but you get rid of the negative because we don't have negative lengths. Okay, finding the distance between these points. So let me do the graphing portion first here. I'm going to do one of them and one from here. The midpoint is the easiest one. When you are given 2 points on a graph and you are asked to find the distance, and this is something I was teaching earlier, I believe it was last week on one of my other classes, is you can sit there and extract the points, okay, and then do the distance formula like we're going to do up here. Okay, but don't do it. It's just a lot more work. What you want to do is create a right triangle. Because this formula is the Pythagorean. Whether you make it up here or down here, it doesn't matter. The distance between these 2 points is basically the hypotenuse of that right triangle. Okay, so your job is to count the spaces. 1, 2, 3, 4, 5, 6, 7. That's 7 units. Count 1, 2, 3, 4, 5, 6, and that's another 7 units. This is not the slope, okay? So those are the side lengths of this triangle, and so you set them up. This is A, and this is B. You have 7 squared plus 7 squared equals C squared. There's no need for you to know the points, okay? That's 49 plus 49 equals C squared, and that gives you 98. Now this one is not a pretty number, which is fine. So depending on what the book wants, the book might want a reduced radical, or they might want the square root of 98. So when I just take the square root of 98, C is approximately 9.9. I mean, it's close to 100, which is why that's close, really close to 10. Okay, and you could do the same thing with this. It doesn't matter if you draw the triangle going this way. Just make sure that these make a 90 degrees, or you go this way. Doesn't matter which triangle you look at, right? This one I could have gone up and then like that, but it's the same dimensions, right? This side is still 7, this side is still 7, that creates a square or rectangle in this case. Okay, now let's find the distance without having a graph. So the distance formula, which is maybe another formula you want to write down, is basically the Pythagorean theorem. Instead of a squared and b squared in here, you've got the difference in x's and the difference in y's because you've got points now. X2 minus x1. And it doesn't matter if you put the 1 or the 2 first. It really doesn't matter as long as you keep it consistent. Y2 minus y1. So if you want to label them, you can be my guest. X1, Y1, X2, Y2. And just plug in the formula. Okay, so X's with X's, Y's with Y's, always. Never subtract an X with a Y. That's fairly illegal, very, very illegal. So let's subtract. So that's -6 minus a -7. Oops. Squared plus, there's always a plus in here. And then I'm going to take my -2 minus a -1. Because they're double negatives. And all I'm going to do is just put that as a positive, just because I write so big. Okay, and that gives me a 1 plus, and that gives me a -1. All right, anytime you have any of these distance formula problems, let me move my box a little bit further up. Anytime you have any of these distance problems, whatever comes out of here, after you square it, it's going to have to be positive. So you might have negatives inside, but when you square them, they better become positive. So 1 squared is 1. -1 squared is still 1. Okay, so the distance is going to be square root of 2. You will not have ever, ever, ever a negative underneath the radical. If you do, it means you made a mistake. So you might have it, yes, but you made a mistake. There's no going about that. Okay. All right. In terms of the midpoint is basically the addition now. You're adding in this case of the x's and cutting it in half. And you're adding the y's and cutting that in half. Okay. So let's do this one because it looks like it's more complicated. X1, Y1, X2, Y2. They're fairly simple. You take each of the x's, you add them, cut it in half, put a comma, and do the same thing with the y's. 8 plus -3 over 2. If you end up with fractions, it is what it is. You're not plotting them or doing anything with them. You're just doing your best. So these two are same signs. So you're going to add them. And that's it. Like, leave it like that. There's no need to divide or anything. I mean, this will give you a nice decimal, but you don't have to. 8 minus 3 is 5. And you're done. That's all you have to do, right? It's not too bad. Add your x's, divide by 2. Add your y's, divide by 2. By adding, I mean putting them together. Sometimes you'll end up subtracting like we did in this case, right? That's what adding means. All right, let's do a little bit of function notation. And at the end, I'll be doing some of this in the back. We'll practice that more in class. But here, function notation just states that a graph does not share an x in 2 places, right? And I went over this the last time I taught the class. So when you have a graph, when you pass a vertical line, no 2 points touch a vertical line. It means that that x does not get shared twice. Remember, never repeat your x's. So for this problem, why is this crooked? For this problem, if they ask you, let's just do something simple like this one. Okay, let's take this equation. If they ask you to find f of 3, that means your x value is 3. What is the y value? That's your input. It's a shorthand of asking if x equals 3, what is y? That whole sentence gets taken care by just this symbol. So it means that if I were to cut this off the page, grab it and dump it on here, this 3, oh gosh, that's not the right one. This 3, if I get this, I cut it and I put it here, that 3 is going to replace every x, right? That 3 is going to replace every x, and therefore it's going to replace there and there. Okay, let me zoom in just a bit and actually do the work. So this will be f of 3. So I'm only doing this one, I'm doing B. equals 3 times 3 minus 3 squared plus 2. I always have a habit of putting the numbers squared, even if I know this is going to be positive, you still get in the habit of putting them in parentheses. So you follow order of operations, PEMDAS. Here I multiply 9 minus, this is 9, plus 2. And it turns out that I get 2. 2 is the answer. Okay, a lot of students will do the following. They'll have f of 3, and they'll be working downward. So we'll get something like that. Oh, sorry, I moved the mouse somewhere else. And they'll think that they're solving for f, so they divide by 3. That's not correct. This is not good. Don't do that, please. F of 3 means x is 3. What is y? So when you are plugging in a 3 in for x, whatever you get out of it is your y value. So if I wanted to plot, this is an actual point on the graph. This is a parabola that you will see and you've seen in your previous math classes. It's a sad parabola, it's a sad happy face. So your point would be 3, comma 2. That's an actual point on that happy or sad parabola. In this case, it's a sad parabola. So on that sad parabola, you will find the point 3, comma 2. Right? So whenever it asks you to find g of for whatever function that is, that's just the name of it. Okay, so this is called, let's say, Fernando. This is Gustavo, right? So that's just their names of those specific functions. Okay, rather than stating y1, y2. For these ones that have variables, we'll go ahead and do one of those. Let's do this one, okay? So they give you f of x equals 7 minus 3x. And they ask you to find f of 8 plus 3. It just means that you're going to take this whole piece and replace it in here, and then it's going to replace it there. So if I cut this out of the page and I dump it on top of this, it'll look like that. Right? That whole thing just replace this. So everywhere x used to be, now it's going to become 8 plus 3. And all you have to do is make it look pretty. You don't work or do anything with the left side, ever. And I know this doesn't make sense, but it's just getting you to work with algebra. And then you make it look as pretty as you can. Negative 3a minus 2. So f of 8 plus 3 equals this whole piece right here. You don't do anything with the left side. Nothing at all. Okay, so practice these function notations, how to plug in numbers, how to plug in variables, how to plug in all these expressions. Okay. Right. The last thing I'm going to do is state if this is a function. I'm going to zoom out just a bit and not do all of them. And then state the domain and range and roster notation. So the domain is how far this graph goes left and right. The range is how far it goes up, down. Okay, so we're going to do both interval and roster. I'm going to close this. I forgot to do that. And let's see. We'll start off with an easy one. We'll start off with D. I'm going to have to use another sheet of paper to write the answers to. Okay. All right. Is the graph a function, yes or no? A function is when you pass a vertical line everywhere on the graph and it only touches at one point. So boom, 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 a whole bunch of lines, left and right, left and right, left and right, and then everywhere 1 point, 1 point, 1 point, 1. Everywhere, vertical line, 1 point. If it touches more than 2 points, not a function. So if I pass it here, 1 point. But if I move the line anywhere inside, it touches more than 1 point. That is not a function. Right? Not a function. Okay, that's the first thing. That was the easiest part. Okay. The second part is finding the domain and the range. So what you want to ask yourself is if you can enclose this shape into a box. Some boxes, as you have seen, are completely closed, like a cube, a Rubik's cube, that's like enclosed, right? But sometimes when you order something from Amazon, right, you have a box that's closed, and then you open it up from the top, and now it's at open from the top, right? So that's what basically you're trying to see is how far the left and the right go from the domain. I apologize for the train, and the top and bottom go. So what you're going to do is for the domain, okay, the domain runs left and right. So if something's running left and right, how do you make it stop? Boom, you put a vertical line, right, to make it stop. So that's what you're going to do. You're going to use vertical lines to see if you can encompass or enclose that shape. Sometimes you can't. For the range, you're going to use two horizontal lines. The range is the Y value. So if you're going up and down the stairs, boom, put a ceiling, boom, put a floor, and it'll make that stop. Sometimes you can't, sometimes you can't. So this is the X value. This is the Y value. This is the longest, most annoying train ever, every night. So anyway, so what I'm going to do is I'm going to take I'm going to do the domain. So I'm going to run two vertical lines, and I'm going to see if I can enclose my shape, which, like I said, this is the easiest one. So if I start from here, nothing is touching the graph. Remember, the graph is this circle. So if I literally start right here at the edge, I can start it there. So my graph starts from that point, which is negative 1, 2, 3, 4. Assuming they're all going by ones, that's a negative 4. And can I make another stop on the right-hand side? Yeah, it literally stops here. So you're basically telling me how far your graph goes. And it literally only goes from negative 4 to 4. You're not going to find any X values outside of that because there's no part of the graph on the left or on the right side of those two vertical lines. So my domain, if we're going to write this in roster notation, it's going to look a little bit different than interval, of course. We'll do, which one should we do first? We'll do the interval notation, okay? And then the roster. Okay, the interval notation, you just state the numbers from where to where. So it's going from left, negative 4 to 4, and you don't write any variables. Now, if it touches those numbers, then you put brackets. If they didn't, you put parentheses. You also put parentheses over infinities, all right? Okay, to put this into roster, there is a page on your online book in which it states that it's all the values between negative 4 and 4. So you give it the letter X because the domain is the X. You put the bar or a colon, whatever you want. And the way you write this is the X values. So all the X values are between negative 4 and 4. Okay, so these are less than or equal to because these are brackets. Remember those spaces I gave you? Okay, so these brackets go with these symbols. So the roster is a little bit more like an inequality versus these where they don't have numbers, okay? The range, let's go ahead and do the range. I'm not going to get rid of these lines. Now I'm going to think, what two lines can I put in order to make it stop or enclose my shape? So I notice that if I do this at this point and here, okay, that'll enclose my shape. So actually I can make I can actually say that my shape is included in this box. So my range is going to go from 1, 2, 3, 4, negative 4. So the lowest value on that circle or that graph is going to be negative 4. The highest is 4. And so it turns out that the range and the domain are going to be the same in the interval notation style. However, the roster is very similar, but you do have to put a Y. And it goes from negative 4 to 4. but you do have to put that y value. You do have to make that change in the variable. Okay, the roster notation, you always have to state the variable. So I'm only going to do one. We will do more in class. Okay, but that's basically how the function notation, the functions work, and how domain and range are. Some of these are a bit more complicated. They look more complicated, but once you get the hang of it, you'll be fine. We'll practice more of these in class. Okay, thank you so much. This is a review for chapter 1. It's fairly concise as to what you need to know, and definitely go through the homework questions, which are very similar to this and might lead up to some of the more harder questions. So please practice that. We will be starting chapter 2. Hopefully soon you can start it, and that'll be it. Okay, I'm going to stop my share now. I'm going to stop it, and I'm going to stop the recording.